How's it going, everybody? So, today in this lesson, we will be taking a look at distance time graph. Okay, so first, let's try to understand why we need these graphs, right? So, let's take a look at this example right here of a car. Okay, so we have a car over here, or it could be a bus, or it could be anything. Okay, so looks like most students here come to school in a bus. So imagine this is a bus instead of a car, right? So let's say a student is right over here. Let's say this is Bob, okay, wearing his cap, and he makes a bet with his friend that he can outrun this bus or car. This is Welling, right? This is Welling, and if this is Woolwich, right? So Bob is placing a 20 pounds bet with his friend that he can run faster from Woolwich to Welling than this car or a bus. So let's imagine this. If the route was completely straight, right, then chances are the bus or the car will win over Bob, right? This is Bob, right? Bob over here, right? But we know that's not always the case, especially during school hours, right? It takes forever to get to school or back to work, back to home during rush hours, isn't it? Because there are lots of cars on the road, there are roundabouts, there may be some roundabouts over here and cars coming in from all directions and you have to wait for them to pass. There might be a long line of cars over here. There might be bus stops over here one, and other bus stops over here, right? There may be several different factors affecting the time that Bob takes or the bus takes to reach from Welling to Woolwich, right? So let's say they start off together. Then they make this bet that Bob makes this bet that he can run faster than the bus or the car, and he will reach Woolwich before that, right? So let's say what factors could influence this journey, right? So Bob could start running, right? And this bus could start running as well, bus or car, right? And this bus may go till here and it may encounter initially the car or bus, it may run faster than Bob, right? And it may encounter a long list of cars over here, long line of cars, right? There may be some bus stops that's slowing it down, and Bob also might be slowing down, let's say to catch a breath. He may be cycling or he may be running, whatever, right? And he may wait for a while to catch a breath, wait for a while to check the time, check his phone notification, or drink some water, or something like that, right? So they may slow down at different points in time, right? So if you want to describe this whole journey to somebody, it will take a lot of sentences. You'll need to keep on talking, right? Bob stopped over here, then he drank water over here, right? It's gonna be a waste of our time, isn't it? So wish there was a easier way to represent all of this information, right? And we have exactly that tool that we are going to be discussing today in this class, and that is the distance time graph. Okay, it plots the distance an object travels against the time it takes to travel. So let's take a look at it. Okay, so let's take a look at this slide, right? We have this same car over here, right? It starts over here, and when you take a look at this, what do you call this? This graphing sheet. You can see that we plot time over here in this axis, and then we plot distance along this axis, right? So let's see, this is the car right over here, and this is the distance that the car travels along this road, okay? So it could travel 20 meters, 40 meters, 50, 60, 70, 80, 90, right? And it could travel from Welling to Woolwich. The road is not straight, we know that, but still, for simplicity, let's imagine that it's a straight road, right? So let's start a timer over here as well, right? So let's see, I'm gonna start a timer over here as well. Okay, so let's say this is our stopwatch right here, right? I'm bad at drawing, so Imagine this is our stopwatch right over here, right? And then we start calculating the time, it takes for this car to travel along this route. So one of the first things you can notice over here is, let's say in the first 3 seconds, the car travels a distance of 60 meters, right? This car goes along from here till here, right? And this car is here now, okay? And it has traveled a distance of how long? How much? 60 meters, right? Because this is represented by the distance. So this travels a distance of 60 meters, isn't it? Right? And the time it took to travel this distance, that is 3 seconds. So I could write it as this as a distance as d and time as t. So the distance traveled by the car would be 60 meters and the time would be 3 seconds, right? And then this car travels along further, right? And we can take a look at this graph and see, you know, from 3 seconds to 4 seconds. In another 1 second, the distance that this car travels would be another 60 to 80 is 20 meters, right? So it travels another 20 meters in another 1 second. This is the fourth second, it travels 80 meters. So this is what we mean by distance time graph, right? So initially the car, began over here, and as time went on, right, this car started moving forward, right? And in 3 seconds, you know this is the time axis. So in 3 seconds the car travels a distance of 60 meters, right? And in another one more second, you know the car travels from here to here, right? So over here, then something interesting happens over here. So we can see, why is this line flat? Is this car moving or not moving? So let's try to make a sense of this, okay? So let's say this car reaches this place, okay? So, and imagine, or maybe it's better to write it like this. So let's say this car reaches this place instead, right? So let's actually imagine the car being over here, right? And there's a traffic light over here. So what happens? As the time, the traffic light is red, okay? So as the time passes, right, the time is so far is 4 seconds over here, right? In the fifth second it still stays here, it doesn't move forward because the traffic light is red, right? And in the next 1 second it's still right over here, right? So a flat line in a distance time graph represents a object being stationary, like it's not moving forward, right? So as time passes over here, the car is stationary over here, right? So at 6 seconds, the light turns green, and then the car starts moving again. So at 6 seconds, the car starts moving again along this road. And let's see, from 6 seconds to 8 seconds, in the next 2 seconds, the car travels a distance of how long? Let's see. Let's start putting a timer over here. Okay. The car starts moving really fast. Okay. And it reaches over here. So in the next 2 seconds, the time in our clock is 2 seconds, right? So in the next 2 seconds, imagine that the car traveled a distance of this long. So that is going to be how much? 80 to 20, that is 20 meters, right? Another 20 meters, 20 meters, 20 meters, 20 meters, right? So total of 100 meters. So imagine in the next 2 seconds, the car travels a distance of how long? 100 meters, right? So this is the distance that this car travels in the next 2 seconds. So it looks like the car is traveling really kind of like a faster than it traveled over here, right? Because it didn't travel so much distance. So over here in 2 seconds it traveled a distance of 100 meters, right? So we plot a point over here. In the next 2 seconds it travels a distance of 100 meters, reaching 180 meters from the beginning point, right? So finally, again in the next 2 seconds, 8 to 9, 9 to 10, it again travels a distance of from here to here. So we have to see this thing. 80 to 20, 20, another 40 meters, right? So we can answer these questions over here. How far does the car travel in the first 3 seconds? We can take a look at the graph. In the first 3 seconds, the distance that the car traveled is 60 meters. So next question is, for how long was the car stationary? Stationary means even if the time was going on, see, even if the time was going on, the car did not move any further along the road, right? So for 2 seconds, the car was stationary. Finally, what was the car's greatest speed, right? We all know what speed is. It is distance traveled by time taken, right? So in this thing over here, we can see that this section represents the largest amount of speed, because in 2 seconds it traveled a distance of how long? 100 meters, right? So 100 by 2 is 50 meters per second, right? So basically, so this is rise over run, right? So we can see from this whole thing that the speed is represented by the gradient of a graph, right? The more the gradient, the steeper this line is. If this line is straight, you know, it travels, well, let's say instead of this thing, imagine this line being like this, right? Imagine this line being like this. What can we tell from this thing? So in 1 second, the car traveled this much distance, right? 20, 40, 60, 80, 100, right? 120, 140. So in 1 second, it traveled 140. So we can see that, the more straight this line is, the more will be the speed of the car, right? So finally, our last question is, what's the car's average speed for the whole journey, right? So average speed means the total distance traveled divided by time taken by the car to travel that distance, right? So the total distance traveled is, it was at this 0 point, right? So we can see it moved all the way in different places, and all the way it reached over here. So the maximum amount of distance this car traveled was 220 meters. And the time it took to travel that distance, that was 10 seconds, right? So 220 divided by 10 seconds would give us how much? 22, no, what, 22 meters per second? Yep, so that is going to be our answer for this thing. So 22 meters per second, right? So now let's try to work through a problem together. Okay, so we have lots of problem over here, right? So let's try to take a look at a easy problem. Okay, let's try to take a look at this problem right over here. Okay, so the graph shows a cyclist journey from home to the next big city and back, right? How long in total was the cyclist stationary during the journey, right? So we know from our fact that, what does this stationary mean? Stationary means, let me see this. Stationary means something is not moving, right? Let's say if I'm traveling in a bicycle, right? And going from this particular place to another particular place, and if I stay stopped over here, as the time passes on, I have not moved any further distance, then I'm stationary, right? So we can see from over here in this figure that cyclist starts at the, like time equals to 0 hour. No amount of time has passed, right? So looks like in the first 1 hour and a little bit more, right, it travels a distance of this long, right? And then we can see that it's stationary for this long, right? It's stationary again for this long, right? So let's try to figure out the total amount of time uh, that it takes to reach this point, right? So let's see. Sorry, I was distracted by this message. So let's see how long in total was the cyclist stationary during this journey. So let's first try to figure out the units over here, right? So from here to here, looks like this is 1 hour, right? Here to here, that is another 1 hour, right? So there's a gap in between. So this must be half an hour. This half of 1 hour is like half hour, isn't it? So this is 30 minutes, this is 30 minutes, this is 30 minutes. So it looks like each of these boxes represent 30 minutes because this is exactly half of an hour, right? Now let's try to figure out the units along this axis, distance axis. So each of these units represent 10 miles, isn't it? So from 0 to 10, that's 10 miles. So half of that is 5 miles. So it looks like each of these units represent 5 miles. This is 5 miles, 5 miles, 5 miles. So we are all good to go now. Each of the units along this axis represent how much time? 30 minutes. And how much distance? 5 miles, right? So we can see over here that this guy, the cyclist, he was stationary for 30 minutes over here, right? And he was again stationary for 30 minutes and another 30 minutes. So that's 1 hour, right? We can see from here as well, 3 to 4, right? You can go all the way up here. So from 3 to 4, he was stationary for 1 hour and then half hour more. So he was stationary for how long? 1.5 hour. Got it? So this is clear here. Now let's take a look at the next part over here. How far did the cyclist travel in total? So we know from the beginning that distance is represented by this axis, right? So for the first, say 30, 30, 30, this time it traveled a distance of, how much is this? 15 miles, right? And again, it was stationary, it did not travel for 1 second. And for the next time unit, it traveled till, this is 30, so 35, right? So in total, from here to here, it traveled a distance of, imagine the cyclist cycling along this road, right? So he traveled along this distance axis, right? He traveled a distance of 35 miles still here. This is 30, so 35. And then while coming back again, he traveled another 35 miles, isn't it? So let's imagine the cyclist being over here. He reached this big city, right? Next big city, right? So when he reached over here, he was stationary over here. Maybe he saw all the people he was hanging around. I don't know, like he was just staying in the cycle and looking around at the birds and the trees and everything, right? So he did not move any further. So he was stationary. For the next 30 minutes, he did not move any further. For the next 30 minutes, he did not move any further again. So what he decided to do was, after that, he decided to come back, isn't it? So in the next 30 minutes, he traveled back a distance of, looks like this is how much? 7 miles. In the next 1 hour, he traveled this distance, right? In the next whatever unit of time, right? He traveled this whole distance of 35 miles, isn't it? Right? In time, how much? 30, 30, 30, 30. That's 1.5 hour. He traveled back 35 miles, isn't it? First he went in like 30, 30, 30, 30, 30 over here, one more 30. So in this amount of time, he traveled a distance of this much, 35 miles. And he again traveled back 35 miles. So the total distance he traveled was 70, what? 70 miles, isn't it? Yep, so it's all clear here. So, what was the cyclist's speed on the way home? So, how do you calculate speed? Distance traveled by time taken, isn't it? So, the distance traveled on his way back home is this thing, 35 miles, isn't it? So, that's 35 miles, okay? And then the time taken is, how long did it take to travel from here back home? See, this is 30 minutes, 30 minutes, 30 minutes, 30 minutes, 30 minutes. So that's 1, 2, 3, 4, 5 times 30 minutes, right? 4 times 30 minutes would make 2 hours. And then one more 0.5, that would make 35 over 2.5 hours, isn't it? So, or you can take a look at here as well. So 4 to 5 1 hour, 5 to 6 2 hours, and then 6 to this one 2.5 hours. So 35 miles divided by 2.5 hours, that is going to be speed. So what was the cyclist's greatest speed? So, like I told you before, right? The more straight like this whole thing is, the more steeper this is, right? That will be the that will represent the increase in speed, right? The greatest speed. Because let's see, from eyeballing it, we can tell that in 1 hour we travel. This section looks like this is the steepest one, isn't it? So we can deduce from that, or we can check it manually as well, that he in 30 minutes, that will be 1 hour. In 1 hour, he traveled the distance of, that is 5, 10, 15, 20 miles, right? So he traveled a distance of 20 miles in 1 hour. So his speed would be 20 miles per hour, isn't it? Let's check our answers. So let's see. So this thing over here. Okay, so 20 miles per hour. So this was, how did they get? So everything else is correct. Let's see what happened here. What was the cyclist's speed on the way home? So 35 divided by 2.5. I guess 35 by 2.5 is 14. Let's check. Okay, 35 by 2.5. Yep, that's 14. Yep, looks like everything is right. So if we want to try some other problem now, we can try this problem. And looks like all the problems are basically the same. You just need to figure out the units of time in between this, this axis. For example, this might get quite tricky, but let's take a look at this. Okay, so from here to here, that's 50 miles, right? So what does each unit represent? Let's start counting. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like this is roughly 10 units. So 50 divided by 10 means each of these units are 5 miles. So that makes it easier. And so you can do this problem as well. There's a couple of different problems here. And this problem looks like it's uh, quite interesting. So we can try to solve this one as well. And this one too. So let's see. Let's take a look at this problem quickly. Okay. So what is the train travels from Goldenrod City to Saffron City. The train leaves at 9:15 and stops at Route 32 along the way. The distance traveled graph, time graph below shows the train's journey. What is the distance between Goldenrod City and Route 32? So looks like Goldenrod City to Route 32. Because it travels from Goldenrod City to Saffron City. So Goldenrod City to Route 32 along the way. So this is Route 32. So let's try to solve this problem before our time runs out. We have about 5 minutes. So what is the distance between Goldenrod City and Route 32? From here till here, right? So from in total it traveled from 0 miles till maximum of this time. So we need to figure out this height right over here, right? So we can see clearly from our picture that till here it is 100 miles, right? So each unit represents 5 miles. So 5 and then another 5 would make it how long? That will make it 100. Let's see. Till here, see, you can see from here. Till here, it's 100, isn't it? And then these two units would represent 5 plus 5 is 10 miles. So that will be 110 miles, isn't it? That's the distance between Goldenrod City and Route 32. So the next question is asking us is how long did the train stay at Route 32? So we have reached Route 32 over here. So looks like this is the time that the train spent at Route 32, whatever the station is. Okay. So one more time, reminding you of all why this is the time is spent in this one stationary at this Route 32, because as the time passes on, this train is not moving along further along this distance axis, right? So the time would be, we figured out before, or we didn't, let's see. Okay. So this is 9, so 9 to 10. In between 9 to 10, there are 1, 2, 3, 4 gaps, right? So imagine a clock over here, right? And not a clock actually. Let me give you another example. So basically this whole distance, this is 1 hour, right? So what will you get if you divide up 1 hour into four different parts? Actually, clock example might work as well, because if this is the minute switch of the clock, right? It goes around this whole thing that will make it 1 hour, right? So what happens if we divide this 1 hour into four different pieces? One, two, three, four different pieces. I'm gonna make a cut right over here, like we cut a cake, and so we can see that each of these would be 15 minutes, right? So this would be 15 minutes, 1, 5, 15 minutes. So now it's very easy to calculate the amount of time spent at this Route 32 station. That would be 15 minutes plus another 15 minutes. That would make it 30 minutes of staying at this Route 32 station. So let's take a look at the last question and probably we'll be done for this session. So what speed did the train travel between Route 32 and Saffron City? So Route 32 to Saffron City, right? Because it's moving from Goldenrod City, Route 32, and from Route 32 to Saffron City. So it's quite easy. Distance traveled by time taken. So this is the distance traveled, isn't it? Because it travels from here to here. So, in a little bit of time, it travels this distance, more amount of time, it travels this distance, and furthermore amount of time. So this is the amount of time, and this is the distance that it traveled in that amount of time, right? So distance traveled by time taken would give us our speed. So the distance traveled over here looks like it would be, we need to calculate. So we are at, let's see, moving along further along this axis, we figured that this is 110, right? So 110, so this is 200, so we can move back further. 200 to 50, that's 50, right? And then 50 all the way down to 110, 110 to 50, 10, 20, 30, 40, 50, right? 40 and then 50, that would be 90. Looks like this is 90 miles, and the time would be 15, 15, 15. That would be 45 minutes, right? So the speed would be 2 miles per what per hour, isn't it? This is in 45 minutes, right? So 2 miles per minute, or you can change it into one of the standard units. Okay, did we do this thing wrong or something when it comes to, well, I guess this is the units are correct. So yeah, you gotta watch the units, because over here we were in minutes, right? So I guess we are done for this. You can try a couple of different problems. This one looks interesting, so taking a look quickly at this. 5 distance travel graphs are shown. Each box represents one graph. Write the letter of the correct graph next to its description. Khalid walked home slowly from his friend's house. So which might it be? So yeah, maybe it's this one, right? Let's say Sophie walked to school, stopped to look at her watch, realized she was late, and then started running. Okay, so it looks like Sophie is walking. So we can take a quick look at this problem. Okay, so I'm going to quickly draw this axis right over here. So we have this thing. So Sophie walked to school, right? She's walking at a slow speed, and then she stopped for a while to take a look at her watch, right? And then she realized she was running late, so she started running. Means before she, in this amount of time she covered this sorry, in this amount of time she covered this distance, right? Now further along, in the same amount of time, she's gonna cover much more distance, right? So this is going to be her new graph, right? She suddenly increases her speed, right? So finally our graph would look like this. She's going from home to school. Let me try a different color that's much more unique. So she's going, school from her home. She stops to take a look at her watch, and she runs along. In justifying this, we can take a look at the time over here. So in this amount of time, she travels this much distance, right? and then now in the same amount of time, she needs to travel more distance than this, right? So that's why she needs to go much more distance in the same amount of time when she runs, right? That's the reason why this is much more steeper. So looks like the correct answer would be something like this. Okay, so our time is up. I thank you for watching this, and I'll see you guys in the next video.